Hello everyone, welcome to the SACM Virtual Scientific Seminar for the 2020. I hope you're all enjoying it. I would be introducing you all to the 8 odd presentations in the Engineering and Information Technology track. Before I do so, I think it would be apt to say a few words about myself and in doing so introduce myself as well. My name is Farooq and I am a full-time academic staff member at the School of Computer Science at the University of Technology, Sydney. I am based at the School of Computer Science and I'm also the head of discipline for software engineering at UTS. There are 1/3 of the School of Computer Science is in the software engineering discipline, and I provide leadership to one of the 3 disciplines in the School of Computer Science at UTS. My areas of active interests are in fog computing, machine learning, and blockchain technologies. I completed my PhD in the year 2007 and I did my PhD in service oriented environments, which many of you would perhaps know is a precursor to the modern day cloud computing and also fog computing as well. So, please allow me to introduce you all to the 8 odd presentations in the engineering and IT field in this virtual seminar. So the first presentation is titled Cybersecurity Policy Frameworks in Saudi Arabia's Smart Cities. And the presenter is Nawaf Al-Halafi. This is quite an interesting and very timely topical area. Cybersecurity policies have to be grounded and have to be based in a given area of context. And in this area, I can see that Nawaf is in particular trying to see how she could apply the developed cybersecurity policy framework to cities within Saudi Arabia. So that's quite an important area of work and study. The next topic for presentation is blockchain for IoT, and the presenter is Fahad Al-Kurdi. So again, this is a very important topic. It's a very timely topic in the sense that there is a lot of work in the area of blockchain, and parallelly there is a lot of work in the area of IoT. But there is very little work that brings the two together. So in this research, Fahad is in particular exploring how blockchain technologies can be made amenable for the IoT frameworks. That's very important line of inquiry. Moving on, the third topic for presentation is optimization of architectural building design parameters on students' thermal comfort and energy consumption in educational buildings. Again, this is a topic that is mostly in the area of building design and those things, but very pertinently so. What this topic does is it sees how we can derive a balance between thermal comfort or user comfort on one side and the energy consumption of the buildings. These are two conflicting parameters, and as Salah has mentioned in here, that in his research he is using multi-objective optimization methods to come up with an overall architectural framework. And more importantly, I was very pleased to say and see that he is implementing his approach in an educational building within Australia. So that's excellent. The next topic for presentation is titled A Deep Learning Based Collaborative Neural Network Framework for Recommender System. And the presenter's name is Maram Abdurrahman Al Maghribi. So again, this is a very important piece of research in the sense that recommender systems have been there for a good 15 years at the very least. You would find a plethora of work in recommender systems. However, most of these recommender systems, if not all, are based on a specific type of recommendation generation method known as collaborative filtering. So, and while that has served recommender systems very well for the past 15-20 years, with the increased generation of content that is anticipated in the next few years, it's unlikely to be the best recommendation method approach. So to counter that, in this research, moving away from collaborative filtering, a deep learning based framework has been used. So this is again a fresh line of research, fresh line of inquiry, and very good topic for research. Moving on, the next topic for research is titled Detection of Sleep Apnea from ECG Signals. And the presenter is Haifa Muhammad Al Mutairi. So, sleep apnea is a fairly common disorder that happens to occur in a significant percentage of the population. And if not managed and if not diagnosed early, it can lead to further complications down the line. So while there have been many different technology based approaches to detect sleep apnea, like using ECGs or EMGs or EEGs and EOGs as well, this line of inquiry takes a completely different viewpoint, and they propose to use the deep learning based methods, machine learning in particular, but deep learning based methods to proactively detect sleep apnea. Again, that's quite timely, and it is highly impactful research that is being carried out. Then the sixth presentation is titled Visualizing the Monash Microgrid Using a Large Tiled Wall Display. And the presenter is Hala Al Mukhalfi. So, Monash Microgrid is most of the Australian universities, they have ambitions to move on to a net zero carbon very soon into the future, some sooner than others. In that regard, Monash has planned to be carbon zero, or as they call net zero, by 2030. So Monash Microgrid is one of the initiatives around that. And in this particular research, Hala is using the various data and the layers of information and visualizing it, for the Monash microgrid. This study is, as I believe, is qualitative research, and it will be carried out to help to better understand how the microgrid can contribute to net carbon zero for the Monash community. Again, a very important line of inquiry. The seventh presentation is titled Reliability Assessment for Remanufactured Components, and the presenter is Yasser Al-Oqaibi. So Yasser is pursuing a very important line of inquiry here, in the sense that many of us these days, with the push towards renewable sources of energy, and more importantly towards reuse, there is a push towards using remanufactured components from a previous life or from a previous supply chain for that matter. However, the big question mark that lingers in front of our heads is what is the overall reliability of such a remanufactured component or a series of components. So in this research, Yasser is going to investigate and develop approaches and methodology using which the overall reliability can be measured or can be deduced in the first instance. This is very important research in the current day and age wherein there is an increasing use towards reuse from the previous life cycle or the previous chain. Last but not the least is the presentation titled Nanoscale Electronic Properties of Triplet State Engineered Halide Perovskites. And the presenter is Qaeda Saeed Al Osaimi. So, perovskite light emitting diodes, this is a relatively new type of LED technology compared to its other sibling LED technologies, and in that relation, not much is known about the physical as well as the chemical properties and states of these perovskite light emitting diodes. So in that regard, this research aims to break new ground by studying these properties and coming up with these mechanisms which can be used to find out the properties of these perovskite light emitting diodes. So these are the 8 odd presentations or so that you will be presented during this seminar. I hope you enjoy these 8 presentations as much as I did reading through them about their abstracts and about their information. Thank you very much, and I hope you enjoy the seminar.
Assalamu alaikum wa rahmatullah. My name is Nawaf Al-Halafi, PhD student at Latrobe University, Department of Computer Science and Information Technology. My topic is cybersecurity policy framework in Saudi Arabia, smart cities. As we know, this presentation 5 minutes maximum, and I will try to do the best to cover all the points. As we know, we have cybersecurity issues. For example, penetration of the new technology in Saudi society, promoting the technology through systemic training programs. Also, we have lack of technical expertise, how to address. And we have also privacy concerns. And how to prepare the nation against potential cyber attacks. In my research, I will focus on cybersecurity policy framework. I will not deal with any cybersecurity technical challenge. As we know, Saudi Arabia has planned to develop smart city, but in the same time, Saudi Arabia faced some technical and organizational issues, prevent the implementation of the project. We have lack of ICT infrastructure to support the adoption of e-government schema. We have privacy concerns, as also technical challenge that cause Saudi Arabia to contend in pressing the plan. We have unsuitable training and the lack of qualified ICT experts for operating the technological system. Additionally, resistance to change and lack of cooperation between the government agencies prevent the implementation of a government project. Actually, my study will affect the performance, culture, and people. For example, improve the security, attracts visitors and investors. That's enhancing the performance of the metropolises. Also, the study will affect the cyber attacks. reducing the cyber attacks. That means we're reducing the operating costs of businesses. Also, my study will affect or will help the government to manage and control the communication of the citizens or share the personal information with third-party corporations. This is my framework. My framework contains 5 core components. The first platform, digital trust. This platform helps the IT administrator to manage and control the communication between users, devices, and systems. The other platforms, uh, privacy by design. This platform integrates confidentiality standards into the design of the structured process and technologies to protect the privacy of citizens. We have also cyber threat intelligence and analysis. This platform explores internal data and detects threats of the technological system. The cyber response and resilience standard, this platform helps smart cities to develop resiliency and deal with possible cyber attack. Uh, we have also cyber competencies and awareness program. This platform helps the government to identify the shortage of cybersecurity experts. This is my framework, and I will say thank you for listening to my presentation. And also, I would like to say thank you for Saudi Arabian Culture Mission to give us this chance to talk about my research. Thank you so much.
Hello everyone, I am Fahad Al-Kurdi and today I'll be presenting a blockchain platform using off-chain storage for securely managing IoT devices. My agenda today will be an introduction, problem definition, system design, simulation and result, and references. Blockchain technology can be described as a network software protocol which allows safe transfer of different kinds of data through the internet without necessarily introducing a third party. Blockchain was originally developed to reinforce cryptocurrency and hence can be used without an intermediary. Therefore, with the rise of security issues in fields like IoT, blockchain technology offers a new form of access control framework which suits most users and enables them to control privacy. IoT is the network of physical objects that features an IP address for internet connectivity and the communication that occurs between these objects and other internet-enabled devices and systems. Blockchain and IoT. Before 2005, IoT networks were completely closed and centralized. Today, IoT have open access networks with centralized clouds. And by 2025 and beyond, and by integrating blockchain and IoT, IoT would have open access networks with a distributed cloud. Problem definition. In a blockchain, as pointed out by Yelihumu and Kasadi, each node must show the full history of the blockchain. This affects transaction time and limit lightweight nodes, such as IoT devices, from joining the network. As time passes, history becomes larger and the problem will be aggravated. For that issue, we have designed a platform using Ethereum to build a blockchain platform using off-chain storage to securely manage IoT devices. The system comprises of 4 models as shown with blue boxes: smart contract model, database model, data interface model, and simulation model. In this figure, you can see how our system works and how are these models connected with the blockchain and with each other. We installed all necessary softwares to be able to run the simulation on each machine. The simulation we did ran the same script on 11 different computers in parallel. 10 of the 11 computers were virtual PCs rented from AWS cloud provider. which ran on Ubuntu 16.10. The simulation ran for 400 seconds for 500 users in the network using 11 virtual machines, during which the scripts generated an average of 306 transactions each, which is 3,366 transactions that were minted in total over the 400 seconds, or 8.4 transactions per second. We simulated for 350 and 150 users and achieved an average of 357 and 372 transactions each, generating an average between 9.8 and 10.23 transactions per second. At the end of the simulation, there were no inconsistencies between the database and the blockchain. We then benchmarked our results with Bitcoin's average transaction rate per second and with the highest Bitcoin's transaction rate of all times. Read and write operations were simulated for 700 seconds with the cloud database and blockchain validation to check if a specific agent has access to a path within the database. It took an average of 0.9 seconds for 150 users, and an average of 2.4 seconds for 300 users, and an average of 3.3 seconds for 500 users. Public and private key were generated in 2.3 seconds when the agent registered with the blockchain for the first time. After that, we benchmarked our result with Bitcoin's average read and write speed, and with the highest Bitcoin read and write speed of all times. For my publication, I have published a paper titled Blockchain and IoT Security, a Survey in ITNAC 2018. And I have a ready paper titled A Blockchain Platform Using Off-Chain Storage to Securely Manage IoT Devices. That is ready for publication for Q1 Journal. These are the list of my references. And that ends my presentation. Thank you very much, and thank you for listening.
Hello everyone, my name is Salah Al-Ghamdi. I'm PhD candidate at the University of Newcastle School of Architecture and Built Environment. The title of my presentation today is Optimization of Architectural Building Design Parameters on Student Thermal Comfort and Energy Consumption in Educational Buildings in New South Wales, Australia. My supervisors are Professor Patrick, Dr. Setmont, and Dr. Darius. This is the content of my presentation today. First of all, I would like to start with some statistics to show the real situation in building sectors. In Australia, buildings are responsible for around 25% of the total energy consumption and around 23% of greenhouse gas emissions. Around 50% of energy consumed by heating, ventilation, and air conditioning systems in Australian universities, as you can see here in these charts. Why I'm going to focus on educational buildings in this study? Based on some statistics, it's important to have the attention to educational buildings because they are required to facilitate student productivity and learning. ASHRAE 55 and ISO 7730 standards define the thermal comfort, and based on their definition, 4 indoor thermal environment variables and 2 personal factors affect on the level of thermal comfort as shown in the figure here. January 2019 was the hottest month on the record in New South Wales, and this is the effect of global warming. Even with the high amount of energy spent on HVAC operations, thermal comfort levels in educational buildings are still poor. One of the difficult questions that face any architect that what's the optimum architectural design in terms of window size, wall, roof construction material, floor area, etc. This question is difficult because there are many conflict objectives regarding to the architectural building design parameters. The architectural building design parameters were determined based on the literature review and previous studies. Even there are some studies done regarding to the effect of architectural building design parameters. There is insufficient studies about predicting thermal comfort and energy consumption and linking the level of student thermal comfort and energy consumption at the same time during the optimization process. Based on the problem statement and research gap, the main research question in this study is how the architectural building design parameters be optimized to improve both the energy consumption and the student thermal comfort in educational buildings. The main aim of this study is to optimize the architectural building design parameters to achieve the highest level of student thermal comfort and energy consumption during the conceptual design stage. The research approach will be used in this study is quantitative method. There are 5 stages to reach the aim of this research. The first stage that I was planning to start is field investigation for 3 random mechanical ventilation mode buildings in the University of Newcastle, which include the indoor physical measurements and student survey. But because the COVID-19 and there is no more face-to-face classes till now, so I was start with stage number 2, which I simulated the building model by using Energy Plus software. Then when the situation will back to the normal, I will use the field investigation to validate the simulation output. Monte Carlo simulations are used to model the probability of different outcomes in a process that cannot easily be predicted due to the intervention of random variables, which is part of stage number 2. The last 2 stages, which is stage number 4 and 5, will come after developed artificial neural network model. Since there are 2 output objectives in this study, which is energy consumption and thermal comfort, multi-objective optimization approach can be formulated to find the optimum result of architectural building design parameters. Also, bivariate analysis will be applied also to determine the empirical relationship between energy consumption and thermal comfort. Simulation allows us to study a system with a longer frame or to study a detailed workings of a system in expanded time. The idea of generate cases or scenarios from the simulation process is to train and validate the artificial neural network model. ANN have a self-learning abilities that enable them to produce better results as more data become available. So I will train a model to predict thermal comfort and energy consumption for any given combination of architectural building design parameters. Feed-forward neural networks with backpropagation training will be used at this study as these are the most commonly applied to engineering and environmental studies. In the studies, I have 15 input nodes, around 11 nodes in the hidden layer, and 2 output nodes. It's very hard to decide how many number of cases I need to train artificial neural network model. And many previous studies use the trial and error method to avoid the overtraining phenomenon, as you can see here in this graph. So I'm going to use the rule of 10 formula. This study is focused only on 15 architectural building design parameters in climate zone number 5 in New South Wales, higher educational buildings, which include classrooms, lectures, theaters, and mechanical ventilation mode buildings. The findings from this research are capable of contributing to the existing body of knowledge within the subject of indoor environmental quality. I'm going to do the field investigation in order to validate the simulation output, and finally I will continue the optimization process to achieve the aim of this study. Thanks for listening.
Hi everyone. First of all, I would thank Saudi Culture Mission in Australia to give us this opportunity for present our research topic in virtual scientific seminars. My name is Maram and I am PhD student at University of Canberra. My research topic is about an offer recommendation system framework based on deep machine learning. In my presentation, I am trying to give you a brief summary about problem and solutions. So what is the problem? The common saying that we are living in the information age. However, we are living in the data age. There are terabytes of data storage in our computer network every day, from information science, medicine, and engineering. This growth is a result of the computerization of our society. That lead to some issues of information retrieval, such as missing value and information with meaning that change over the time. Also, we have Arabic language, which has limited researches and applications of using recommender system. Because Arabic language totally different from English, and we can say that is different from grammar, structure, culture, and so on. Also, there are many business spend a lot of money on advertisement to show customer what they have, and this way not is not guarantee if they can meet each user need. So in my research, I am going to use recommendation system as a solution. So what is the recommendation system? Recommendation system is a computer program that help user to discover product or content by predicting the user rating or review. And there are many applications of recommendation system, such as government. Government use recommender system that help citizens to make decision. Also, the bank use it recommender system to match the client profiles with the information from the system. Also, there are something called internet-based companies, such as Amazon. Amazon used the e-commerce recommender system in their online platforms to assist client in choosing the products to purchase. So in my research, I am going to build a recommendation system based on data mining and deep learning and sentiment analyzing and rating as a solution. So what is data mining? Data mining is extracting or mining data or knowledge from a large number of information. And then I am going to use deep learning technique, which that help to make all this information make sense. And I extract all this information from sentiment analyzing and rating. Sentiment analysis is a process of analyzing people's opinion, and the rating is performance used by user to rate items such as movie, book, music, and so on. In my research, I used the data sets from different way and collected from different way. So I used the public data set and I build website to collect data, which is called data store, and use some data mining technique to extract data from some libraries after, of course, their permissions. So in my research, I used data mining and deep learning to create models. Here, as you can see, I'm going to show you the result of my experimental work to give you a clear picture on my research. So I apply collaborative filtering based multi-stage deep neural network architecture on rating prediction. As you can see, I propose these models and compare with the traditional one. As you can see, our models give 100% for the rating prediction, and the traditional one give 59 and 73%. Also, I use this model to see if this the rating scale impact the recommender system, and of course, our models show 100%, and the traditional one is 59.30% and 63.90%. Also, I used some models on sentiment analyzing for Arabic and English languages. I used the MCNN, the multi-stage convolution neural network, which is the one of the most popular deep neural network. The name is come from mathematical linear operations between matrix called convolution. So I applied this model on the Arabic text and English text and see if the predictor model is give me the right prediction. So here in the first text is so it's positive, and here is negative, and that work perfectly. Also, it work here in the English. As you can see, the MCNN models achieve about overall accuracy 96% compared to 95 achieved by CFD-NN models. In conclusion, as you can see, our model proposed show good performance in Arabic language and English, and to build recommendation system based on rating and sentiments and user personalizations. Our models is going to help many business to improve their services. So thank you for watching, and if you have any comments or questions, please email me. Thank you so much.
Assalamu alaikum. My name is Haifa Muhammad. I'm studying at the University of Western Australia in Perth. Today, I'm going to present my first research problem. The title is Detection of Obstructive Sleep Apnea by ECG Signals using Deep Learning Architecture. The outline of this presentation: first introduction, then proposed approach, and last thing, results. Obstructive sleep apnea is a common chronic sleep syndrome which causes a person to breathe abnormally or stop breathing. It happens when the upper airflow is blocked from 5 to 10 seconds. However, when the upper airflow is blocked partially, it's called hypopnea. The common symptoms of obstructive sleep apnea are snoring, fatigue, morning headache, dry mouth, and tiredness. If these symptoms prolong, also causes some complication disease like cardiovascular disease, blood pressure, and stroke. A study by World Health Organization in 2007, 100 million people were suffering from obstructive sleep apnea. In 2018, this number increased to 1 billion. In clinical, the common procedure used to diagnose obstructive sleep apnea is polysomnography. This procedure is inconvenient because patients need to sleep at hospital from 2 to 3 days, and the patient body connect with multi-electrodes and expensive procedure because it needs nurses, bed, and equipment. The alternative solution is wearable sensor. This sensor can record physiological signals. In my research, I'm using ECG signal, electrocardiography. It records signals from heartbeat. This signal contains from 3 primary waves: P, QRS complex, and T wave, and each wave has a specific duration. As we can see in this picture, normal signal and obstructive sleep apnea signal. We proposed a methodology. First, we processing this signal by normalization. Normalization step can remove noisy signal and artifact. Then we segment this signal 1 minute by minute. After that, we use deep learning. As we know, deep learning has a good accuracy in clinical application, and we use it to detect obstructive sleep apnea. We developed 3 architecture of deep learning, and we got a good result. Thank you for listening.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Yasser Al-Agabi. I'm a PhD candidate at University of New South Wales for the School of Mechanical and Manufacturing Engineering. Today I'm presenting my research project. It's about reliability assessment for remanufacturing components. Our outline today, it's introduction, background, motivation, research gap, and research questions, hypothesis, conceptual framework, and conclusion. I will go a little bit quickly for the introduction and background. We have the concept of sustainability is to, as simple as that, do not waste our natural resources to meet our requirement for today unless that we will compromise the future generation needs in the future. The sustainable manufacturing that we will managing the life cycle of any products from the starting point, we call it the cradle, until the ending point, which is the grief. The circular economy, that's mean any equipment, an item, and component has to be circulating and reused again and again and again all the time among the circular economy, and we have to transform from linear economy to a circular economy as it shows here in the diagram. Remanufacturing technology is to help us to maintain the circular economy by remanufacture all the components at the end of life stage. To be a successful remanufacturing product, we have to have a reliable product. So we have to discuss reliability. Reliability is a performance measurement and quality index for any product. It has to be dependable, available, capable for a given period of time. In a short explanation, as you can see here is the machining tool here on our left. It is really rusted and at the end of the life stage, then after remanufacturing process, it will return to as good as new. But to be a successful remanufacturing, we have to maintain reliability. What is the motivation that we have today? Okay, this is the first life, which is the new component, and then it's became remanufacturing components. So we have to put in our mind these factors: operation conditions, the maintenance activities, and performance measurements. So out of that, we find out the research gap that we have it through the literature review, that for any successful reliability assessment, you need to find two items: the estimate time to fail, which is the mean time to fail, etc. And the second one is the most important thing is the identifying the thresholds. The thresholds meaning that when you decided this equipment or this item is failed, which is the limitation for any product or any component. So to identify the correct one, the accurate thresholds, you have to bear in mind the usage factor and using and degradation factor. This is the research questions, the hypothesis once again, that to have a successful remanufacturing process, you have to maintain a comprehensive reliability assessment. Our conceptual framework that you have to identify the degradation and aging factor in the lift as a first module by using the operating condition, performance, and maintenance. This ultimately will lead to reliability assessment. Then after that, we will have the successful remanufacturing process. We have two graphs here. You can see is the famous bathtub curve for reliability assessment, which is have the failure rate and the time. It will be fail in the infant mortality for different reason, but then during the useful life, it is like have a constant failure rate without the random failure. And this one is a degradation modeling that it says that for any component, for any items, it degraded on timely basis. And in every time, it is like an age-dependent factor that in every time you use this product, it has to be deteriorate or degrade or decrease in the performance or decrease in the outcome. So this is like a natural process that we have to combine, and we have to compare it in our mind that if we have remanufacturing component, we have to put the degradation modeling in our mind. So this degradation modeling is always affecting the bathtub curve. So this bathtub curve probably will go up a little bit, that it will increase the failure rate because this is a remanufacturing component, is not a brand new one. This is our hypothesis, and we need to approve it by the end of this research project. Thank you very much for listening, and I hope we have presenting nice and promising research topic. Thank you very much.
Assalamu alaikum. Hello, everyone. As we know, the fossil fuels are currently used to produce the most total energy demands in Saudi Arabia. However, according to Saudi Vision 2030, there has been an increasing interest in reducing Saudi Arabians' dependence on oil. As mentioned in the literature review, solar cell based on organic and inorganic halide perovskite materials have recently shown rapidly raising power conversion efficiencies with low manufacturing cost. However, the main challenge faced by researchers is optimizing the long-term device stabilities under operation condition. It is worth noting that there is a trade-off between the stability and efficiency when perovskite solar cells are used. Also, since the perovskite materials is a polycrystalline, so the effect of a grain and the grain boundary on the device performance is a young research area and required more investigation. Regarding to the device stability as well, several studies have shown that the ion migration is the first stage of device degradation, and only nanoscale characterization can be used to study this process. Since the conventional macroscopic measurement cannot infer how much variation exists from grain to grain and within one grain in perovskite materials, which is important to determine how the local changes will affect on the overall device performance. And only nanoscale characterization can be used to investigate this aspect. Based on this consideration, different types of scanning pulp microscopy techniques were used to in my study to controlling and understanding the complex interplay between the morphology, chemical composition, and optoelectronic properties. These are some results from my current work. We have 3 samples. They differ in chemical composition. Let's see how the chemical composition will affect on the topography or the morphology. It can be clearly seen that the presence of organic cation spacer in sample B and C led to decrease the grain size. Now, let's see how the morphology will affect on the optoelectronic properties. After that, these samples were illuminated and the optoelectronic properties were measured. It can be clearly see that in sample A and B, the surface potential and surface conductivity show very significant variation. And this variation might be corresponding to the ion migration or the accumulation of the charges in the grain boundaries. While sample C show uniform and homogeneous optoelectronic properties. This means that implementing an ethyl-methylamine in the chemical composition of quasi-2-dimension perovskite materials is recommended to obtain homogeneous and uniform optoelectronic properties. So in general, it seems that it can be effectively controlling the the optoelectronic properties and the morphology by optimizing the chemical structures or the chemical composition of the device. That's all from my side. Thanks for attention.